Take a deep breath. Imagine we are sitting together beside a small campfire. The sky is turning orange, and the last light is sliding behind the hills. The air is cool, the flames crackle softly. Above us, the first stars appear, one by one, like tiny eyes opening in the dark. If you listen carefully, you can hear the night, a far dog barking, leaves moving, and the quiet rhythm of your own breathing. Now let me ask you something simple. Have you ever wondered how this whole universe began? Not just the Earth, not just our sun, but everything. The space, the time, the stars, and even the light that touches your face. The universe is not only a place, it is a story. And today we will tell that story in easy English, step by step, like walking along a long path with a lantern in your hand. Here is a small fluency exercise. Say these 3 lines slowly. The universe is old. The universe is huge. The universe had a beginning. Good. Clear sentences are strong sentences. Keep this idea in your mind. Every big thing starts from a small beginning. Ready? Let's go to the very first page of the universe. We will not rush. We will use short sentences and clear pictures. If a word is new, I will explain it. If an idea feels big, we will break it into small steps. You can pause after each scene and repeat one key line aloud. That is how fluency grows. At the start, we do not imagine a bomb exploding inside space. We imagine something stranger, space itself beginning. Scientists call this the Big Bang, but the name can be confusing. It was not a bang in the sky. It was the start of the sky. Everything was packed together in a state that was extremely hot and extremely dense. Dense means very crowded. Imagine all the mountains, oceans, and galaxies squeezed into something smaller than a dot you can see. Then the universe began to expand. Expand means to grow bigger, but it did not expand into empty space because there was no empty space outside it. The universe created its own space as it grew. Think of a balloon. When you blow air into it, the surface stretches. The universe was like that, but in every direction at once. Another simple picture is raisin bread. When the dough rises, the raisins move away from each other, not because they are running, but because the bread itself is growing. Very early, expansion may have been extremely fast for a short time. Some scientists call this inflation. You do not need to remember the hard word, just remember the idea. The universe grew quickly, and then it kept growing more calmly. In this early moment, time also began. Before this is a tricky word because time is part of the universe. So we can say this is where our clock starts. Also remember this, expansion does not mean everything is flying from one center. There is no center. Every place sees other places moving away. That is why the universe can be both simple and strange at the same time. In the first tiny fraction of a second, the universe was too hot for atoms. It was like a wild ocean of energy. Energy became matter in small pieces, and matter became energy again. This sounds like magic, but it is a rule of nature. When the universe was young, it was full of fast, invisible particles. As the universe expanded, it cooled. Cooling means losing heat. When it cooled enough, some particles joined together. Quarks formed protons and neutrons, which are parts of atoms. Then, after only a few minutes, the first simple nuclei formed. A nucleus is the center of an atom. Most of these early nuclei were hydrogen and helium with a little bit of lithium. Hydrogen is the lightest element. Helium is also light. These were the first building blocks. Here's a learner-friendly line. The universe cooled, and it made ingredients. Just like a kitchen needs flour and water, the universe needed hydrogen and helium to make stars later. And while this was happening, the universe was also filled with invisible travelers like neutrinos, tiny particles that almost never touch anything. The early universe was busy, even if it was silent. For a long time, light could not travel far. The universe was still like a thick fog because electrons were flying around everywhere. Light kept bumping into them. But about 380,000 years after the beginning, the universe cooled more and atoms formed. Electrons joined nuclei and stayed close. The fog cleared. When the fog cleared, light could finally move freely. That ancient light is still here today. It has traveled for billions of years. We cannot see it with our eyes now because it is stretched and cooled, but scientists can detect it with special tools. They call it the cosmic microwave background. It is like a baby picture of the universe. Imagine that. The sky carries a memory. The universe left a soft echo of its first light, and we can listen to it. If you could see that early sky, it would glow like a warm wall of light. Today, it is colder and quieter, but it is still everywhere, like a soft blanket around the universe. Try these practice sentences. Light was trapped. Then, light was free. The universe left a message. Simple, but powerful. After atoms formed, the universe entered a dark time. There were no stars yet, only huge clouds of gas. Gravity began to pull these clouds together. Gravity is the force that makes things fall and also makes planets and stars form. Slowly, gas gathered into heavier and heavier clumps. Then, about 100 million years after the beginning, the first stars were born. A star is a giant ball of hot gas that shines because of nuclear fusion. Fusion is when small pieces join and release energy. In the center of a star, hydrogen joins to make helium, and light is born. Those first stars were huge and bright. They lived fast and died young. When they died, many exploded as supernovas. A supernova is a giant star explosion. It sounds violent, but it is also creative because it spreads new elements into space. The first stars also helped clear the darkness by changing the surrounding gas, turning it from neutral to bright and active again. The universe was waking up. When many stars gathered together, galaxies formed. A galaxy is a city of stars held by gravity. Our galaxy is called the Milky Way. But long before our sun existed, galaxies were already growing, spinning, and colliding. Some galaxies merged, like two rivers becoming one larger river. Galaxies are not perfectly neat. They have arms, clouds, and empty gaps. They are born, they grow, and sometimes they crash together. Yet, even after a collision, stars usually do not hit each other because space is so wide. Inside stars, new elements formed. Not only hydrogen and helium, but heavier things too. Carbon, oxygen, silicon, and iron. These elements are important. Carbon is in your body. Oxygen is in your breath. Iron is in your blood. Where did they come from? They were forged in stars. When stars died, they scattered these elements like dust across space. Over time, clouds of gas and dust became richer. The universe was learning to build more complex things. It was like a painter collecting more colors. With more colors, the universe could paint planets, rocks, oceans, and eventually life. In the centers of many galaxies, there are also huge black holes. A black hole is a place where gravity is so strong that even light cannot escape. That sounds scary, but black holes can help shape galaxies like a deep drumbeat guiding a song. Remember this line, "We are made from stardust." It is not only poetry, it is a scientific truth. About 4.6 billion years ago, in one calm area of the Milky Way, a new cloud collapsed. It spun like a slow whirlpool. In the center, the sun formed. Around it, leftover dust and gas formed planets. This is how our solar system began. Earth started as a hot, rocky ball. It was hit by many space rocks. Volcanoes poured out gas. The early air had almost no oxygen. It was thick and strange. Then, over a long time, the surface cooled. Water collected. Oceans formed. The moon appeared, likely after a giant collision, and it helped stabilize Earth's tilt, making seasons more steady. This part of the story teaches patience. The universe does not rush. It builds with time. If you want to practice English, repeat this. Small changes, again and again, make a new world. Say it once more. Good. That rhythm is easy to remember. We do not know the exact moment life began, but we have strong ideas. On early Earth, chemistry was active. The oceans were full of minerals. Energy came from sunlight, lightning, and deep-sea heat. In that messy kitchen, simple molecules may have learned to copy themselves. Copying is important. If something can copy itself, it can change and improve over time. The first life was tiny, like simple cells. For billions of years, life stayed small. Then something amazing happened. Some cells learned to use sunlight to make food, and they released oxygen. Slowly, the air changed. Later, some cells learned to work together. They formed more complex cells. Later still, life moved into the sea in many shapes, and much later it walked onto land. Evolution is the process where life changes over many generations. It is slow, but it is powerful. Life faced disasters too, ice ages, volcanoes, and asteroid impacts. Many species died, but life continued. It adapted. It tried new shapes. It kept going. This is a good sentence to practice. Life fell, life rose, and life learned. Very late in the universe's story, humans appeared. Compared to the age of the universe, we are new. But we have one special habit. We ask questions. We look up at the sky and wonder. We build tools. We measure. We write. We share stories. We learned that light has a speed. We learned that stars are far away. We learned that the universe is expanding even now. In fact, the farther a galaxy is, the faster it seems to be moving away. This helps scientists estimate the age of the universe, about 13.8 billion years. We also built telescopes to see deeper. The deeper we look, the further back in time we see, because light takes time to travel. So a telescope is also a time machine. That idea can help your vocabulary. Distance and time are connected in space. When we learn these facts, we are not only collecting information, we are training our minds to think clearly. And clear thinking helps clear speaking. So science stories are also language stories. And here is something beautiful for your English practice. To learn is to travel. When you learn English, you are doing what humans always do. You are reaching out, trying to connect, trying to understand. Now we return to our campfire. The night is darker. The stars are brighter. Still, tonight, the universe feels close. You can point at a star and say, "I am here, and I understand a little." The universe is still expanding. Our sun will shine for billions of years more, and then it will change into a red giant, and later it will become a quiet white dwarf. Earth's future is long and complex, but the universe will continue beyond us. Far in the future, galaxies will drift farther apart. The sky may become quieter. Some stars will burn out. New stars will form less often. Time will keep moving forward. This can feel sad, but it can also feel peaceful, like the last pages of a long book. But the story is not only about endings, it is also about meaning. You are a thinking part of the universe. The universe made stars, then planets, then life, and now a person who can sit by a fire and ask, how did it begin? So here is the final, simple message. The universe began small, grew vast, and created wonder. Speak it slowly, feel the rhythm, and remember, every time you practice English, you add your voice to a very old and very big story. The fire is low now. The wind is gentle. Our journey for today is finished, but your journey of learning and curiosity is just beginning.